All right. So today we are going to discuss the we are going to discuss Scala, and then from next session onwards, maybe today itself, we will start with Spark. All right. All right. So as opposed to our usual program, uh, from the next session onwards, we are going to spend more time into problem solving, real problem solving with Spark and Scala. Not Scala alone, but Spark with Scala. All right. So let me just check if the audio is okay or all right. All right. So looks like audio is okay. And right. So I've started recording. And all right. Hi Ali. Hi Anup. Hi Arslan. Hi Barsa. Hi Jamil. Hi Jitendra. Karthik. Kush. Manjunath. Nada. Nitin. Omkar. Priya. Ramana. Sapna. Stephanie. Tad. And Thomas. All right. Great to have you. Okay, great to have you in today's session. And all right. Okay, so the first question is from Priya. I was unwell yesterday and could not attend the class. Will today's class be fine without yesterday's data? Yes, absolutely. Today's class is totally independent of yesterday. Therefore, there is nothing to worry about missing it. You can again go through the steps that we have done yesterday. Yesterday's session was very interesting because almost everything was hands-on. Okay. So today also we'll try to keep everything as hands-on so that we all feel confident about what we do. And again, the hypothesis that I had was that the hands-on matter a lot is proving to be true when I'm taking a look at my CloudX Lab users. So there are a lot of users who are doing hands-on at CloudX Lab. They're finding it much more useful than their usual classes. Okay, so we have got very brilliant feedback in the last week, and therefore I am planning to spend more time with hands-on. Okay, because the most important purpose of these classes is to kill the inertia of new technology. Second, these second purpose is to be able to get your questions answered. All right. Great. We will stick to the philosophy. And so all of you, whatever, if I'm going into theory a bit, the purpose would be to be able to do a hands-on. Okay. So at any point of time, if you have question, keep typing because I can see your questions parallel to this screen. Okay. So, and I missed one question yesterday. The one question was that will the chat logs be available? And will the chat logs be available? Yes, we'll make the chat logs available to all of you. Let me see where we can update in the LMS. All right. So let me, or maybe we can just share it in a Google Drive and share with all of you. All right. Thank you, Nada. All right. Great. Because we don't want to make our classes too much like professors of Coursera or those places, because I have been pretty bad student just because of my that boring way of teaching things. Okay, and I had to learn everything from scratch, and me being from Okay, so that's the important part I want to convey. So my personal interest is in making all of you hands-on, and luckily for us in today's world, as I was talking to people from Yahoo, okay, there was a senior manager from Yahoo, and there were a few more people from different places. So I was talking to them, and all of them had a single opinion that the definition of a technologist had changed over past few years. Earlier at Yahoo, they would pretend that they don't know the technology so that they don't get the work. But later on, they all realized that if they don't show that they are technologists, their job is at peril and nobody gives them work anymore. So that was common, and that's a common thing which goes on. And instead of focusing only on the certification part, okay, the kind of feedback we are getting from our students at CloudX Lab and students from No Big Data, the we are getting the feedback that because of our lab, people got the job, which means practice directly converts into the good interview. All right. So, okay. So a question from Karthik. Can you just give some live project experience, at least two, where the previous session topics are used and how it is used? Okay. So, all right. So let me deviate a little because this is important and I would love to give this answer. Okay. All right. So where are the chats? Not here. I think it'll be here. Okay. So I love to answer this, and all right. Okay. So at least two examples where the previous topics, whatever we have used. Okay. All right. Let me try to talk about these parts first. Okay, I'll talk about MapReduce with streaming. Okay, and all right. So this is one, and then I'll talk about Pig and Hive. Okay, so let me take the example of my mm, as a first problem that I was trying to solve at InMobi. Okay, the task was to take the logs and convert them into recommendations. Okay, so okay, sure. I'll share yesterday's discussion notes after the session. Okay, so with Mahat is application which gives the recommendations. All right, have I shared this case study before with you? No. All right. Okay, so I'll try to describe what InMobi does. What InMobi does is it it basically displays the ads to the people. When you play a game, the ad that comes is either from Google or InMobi. In the middle of, say, Fruit Ninja or this Subway Surfer, all the ads that come in, they either come from Google or they come from InMobi. Okay. So the challenge that we were given was that there are a lot of users, and can we increase the engagement with them? And the ads that are displayed inside this app are basically small browsers. Okay, I'll try to show you one blog post where I have written a little bit about nitty-gritties. Okay, so all right, so interview. All right, so we have, okay, all right. So what this particular screen shows to you is that there is something happening on the screen. There's a dictionary app, and then there is an advertisement here. Okay, this is the ad. This ad in itself is a small browser. Okay, so when you click on it, it becomes bigger and so on. Now, all right, so the way it works is the mobile devices talks to an ad server, and then advertiser responds with the ad and displays it at the user's screen. Okay, so this is the general way of looking at an ad. Okay, so do you see this screen where the ad is coming? It's nothing but a small browser which is making a call to the web server, and then web server, uh, ad server is displaying the ads which advertisers have created. These advertisers go to the ad server, the admin UI, and they create their advertisements here. Okay. Now, there was an interesting challenge that people come to us, we display only the ads, and we don't provide them any value. So instead of displaying the ads, can we give them any kind of recommendation? Okay. Like, since you are playing this particular game, since you're playing Angry Birds, you might also like to play some other game, or people like you generally also install these apps. Okay, now the key insight is here. So when this app is making a request to our ad server, it is sending along with it the information about what game this user is playing, what is the unique ID of this particular user, what is the IP address of this user, and so on. So the ad server knows. So the ad server knows all the details about the user who is requesting an ad, and then appropriately it gives the ad to the user. The ad server parallelly creates logs, and these logs are saved in the files. Okay, these logs are saved in the files, and these logs were continuously pushed to HDFS. Okay, and you can think of it that, okay, so this data, the complete information is plain text file, and these plain text file were pushed to HDFS, and in HDFS you can have these logs. Okay, everybody clear about what is a log? No? All right. All right. A log is basically a string containing information about the users. Okay. You will see the exercises as part of these courses. Okay. One example of the log I'm going to show you. If you go into the course, okay, in the last session, you will see an exercise. Okay. Here and okay. So we have, all right, let me take a look at project. There was a project here. Okay, so here I'm trying to show you the ad, show you the data from the logs. So the data set is located inside this folder. Okay, so if I go to Hue, okay, the file browser, okay, there if I change the directory to that data Spark project, you'll see that here there is a compressed form of logs. So you can see that from this domain, okay, you can see that this domain, the request has come at this particular time for asking for this URL, this particular image, and the response was successful. Okay, the version was HTTP 1.0 and response was successful, and they were this time. Good. So this is the way the log looks like. Okay, going back to the case study. Now, these logs gave us a lot of details that this user was playing this game for this much time. From this, we figured out that this user plays this app these many times. Okay? Yes, 200 means, I think, yeah, 200 means it's a successful attempt. Okay? As far as I remember. Okay, so this user was playing this particular game these many times. Okay, so first out of the logs, we had to convert the data into this form. And how will you do that? First, okay, first I will, as soon as we converted this into something like this, okay, something of the format like there was, let's say, I'm just taking an example, Kush and Angry Birds, Angry Birds 1. Again, the second request came from Kush, and Kush was playing Angry Bird still. And again, the third ad was shown again in the Angry Birds and so on. So we converted this into this form, and then Manjunath was playing, say, okay, playing, say, Fruit Ninja while the ad request came in. And again, he was playing Fruit Ninja, and next time he was playing Angry Birds. Okay, so this is first we converted logs into this format. Okay, and then we converted these logs. Okay, we converted this into Kush playing Angry Birds 3 times and Manjunath playing Fruit Ninja 2 times and Manjunath playing Angry Birds 1 time. Okay, so now we know like which user likes which game how much. Now, the problem was that there were some users, let's say Ramana, okay, they were like highly addicted to a particular game, let's say Temple Run, okay, and they had like 100, okay. So these values had to be normalized, okay. They had to be normalized to between 0 and 1. Okay, so we use some strategy to normalize it. We call it 5, and rest we call say 0.25 and point something like that. Okay, so if you divide by 20, this becomes 0.15. Okay, all right, and then if you divide Angry Birds by say 0.05. Okay, so we basically converted this into uh, you know the the normalized form from 0 to 5. Okay, so the next step was okay. Next step was to feed it to Mahat, which takes the data in this format: user ID, app ID, and the how much they liked. Okay, then Mahat gave us the suggestions that Kush might want to play Temple Run. Okay, Temple Run, and how much. Okay, so Mahat gave the suggestion like this. All right. The other thing which we did was we basically also kind of grouped by the, we removed the user ID and also found out the most popular games in geography. Okay. If a user has not come before and he's coming for the first time, we tell him that, hey, you may also like to play these games just by showing the most popular game in the geography. Okay. So basically, what I'm trying to say is all of this is looking pretty simple, right? This looking pretty simple. Like you just take the data, maybe load it into SQL and churn it. Now, and also there were a few more steps here. Okay, our target segment was only US. Okay, only US. So we had to remove US data, or remove uh, uh, other data. Okay, now the the important part to understand is that these logs were not simple logs. They were 200 terabyte. Okay, which is 200, which is 200,000 GB. Okay, now as an exercise, if you try to churn 1 GB of data using any of the tools, be it R, be it say Python, be it Microsoft SQL, you will realize that 1 GB is a huge data. And we were talking about 200,000 gigabyte. Okay, so it used to take a couple of hours on around, okay, on around 800 nodes. Okay, did this make sense to you? The problem statement? Great, great. All right, so you can see that the data was humongous, and we needed to first clean the data, then group the data, group by these both IDs, then normalize it, and then pass it to Mahat, and the result, whatever we were showing here, then these results would be given to who? The ad server. Okay, These results will go to the ad server. Make sense to all of you? Okay, great. Now, so what we did mostly was at the time the pig and hive were not very popular, so we ended up running MapReduce streaming. Okay, we ended up running everything through awk and SED via Hadoop streaming. So a question from Saptrishi was the log written into HDFS using Flume? Basically, Flume wasn't popular that time, so we had written our own script. The team, data platform team at InMobi had written their own scripts, which continuously keeps uploading the data into HDFS. Okay, and yes, so all of this we were using the first set of Python program, okay, to convert it into this, and then another Python program, and then another Python program. And all of this was, we were running Python program on Hadoop via Hadoop streaming. Okay, so this was my first attempt. And since my mentor was a Python guy, and I had no experience with Hadoop or other tools at that time, so I just went with the flow, and it was actually very smooth. Okay, it was actually very smooth. Now, there were few challenges. I have listed down those challenges in this case study if you want to study them. So we basically were able to do most of this work using map streaming. But at the same time in the company, lots of people were having something called a tool called internal tool called Yoda. Okay, it provided a interface, the UI, in which you kind of can select the filters and other things. Okay, this got replaced with Hive. Okay, and basically, why did we need Hive is this data that we are talking about, logs again, these logs. All the time when we designed a product, we always took a look at the logs. We tried to understand that how many requests come from which geography, which mobile device, which operating system, and so on. And on what date is the maximum traffic, on what date is the minimum traffic. And so we basically, all the time, product managers needed these logs to be churned. And for that, we were having something called Yoda. It was a UI where we could only select few columns, but it was quite confusing. So Hive made it very much smooth. Okay. We had just created these tables and people could write their SQL queries and generate reports. All right, so that was the real use case of Hive. Most of the product managers which we had at InMobi were pretty good with the SQL. All right, because most of the product managers in Mobi and these other places these days, most of them are very hands-on senior developers. Okay, those who have moved to the product management. All right. All right. So this was my use case with respect to the MapReduce and Hive. All right. Regarding Pig, Pig also comes with a similar use case. And let me talk about, say, HBase. All right. I haven't used HBase yet in a production environment, but I have used a close cousin called Cassandra. Okay. So what does Cassandra do? Cassandra basically makes it possible for the people to uh, store humongous data, and you can query that data using the mm, uh, using the SQL like query. So why were we using Cassandra was, so there was another project. Okay, there was another project in which, after I finished this project called Recommender, we were working on this nice project whereby all the people who are using our mobile platform for showing ad, because there are many users of our InMobi's toolkit. Many people want to display the ads. Okay, so many game developers, many app developers were there. So we wanted to provide these app developers a way of rewarding users in real time. Okay, let's say app developer comes to our interface and says that I want to give everyone one level up who has been stuck in the first level for very long, just to motivate them. So we provided that kind of product that these people could use and could push the coins, rewards, and various other mechanics to the people who are playing the games. Okay, so there the challenge was that all the events that were coming from the phone across the globe were too high. There were too many requests, too much of data was coming continuously to us, and we wanted to bisect this data as and when the user wanted, as and when the game developer wanted to. Okay, and therefore we could not do it with using HDFS, because churning humongous data in HDFS the way we wanted would be very slow, and therefore we settled down for Cassandra, because HSpace wasn't in a very great shape, and HBase did not provide us CQL that point of time, the kind of query language Cassandra provides. So we zeroed down on Cassandra, and in Cassandra we were storing entire data in the column family, in the tables, and whenever the game developer wanted to reward the game players, they will come to our interface, and our interface would query Cassandra, and then then the whole action happens. All right, so that's where I used NoSQL, because there were too many change requests that were coming in. Okay, so I hope this makes sense to all of you. It's little theory, but this is something which I worked on in past. All right. Similarly, in case of NoSQL, the other use case of NoSQL was at Amazon, where my role was to do the image cleaning, image selection, basically the product image that you see. Okay, there we were using a database called Sable. They call it Sable, and Sable is a database from Amazon, which has basically matured from Dynamo. Earlier there was Dynamo, okay, which was very simple key value, but they make now they made it Sable out of it, which is very advanced and very stable. Okay, good. All right. Okay, was I able to answer your questions? I have kept the discussion strictly for the cases which I have handled out of these tools. Okay. All right. So although all of these things what I told you are pretty simple. If data is small, you can get it done in any database. Any database can get you all of this in a very easy manner. So people would do upfront when I looked at the problem, I said, what is so big deal about it? I could just write a Unix shell script and solve everything. Then I realized that it is 200,000 gigabyte data. All right. And then the whole idea, when I did the back of the envelope calculation, the entire thing looked impossible using the tool which I had been using traditionally. Okay, that's where the Hadoop came into play. All right, so today, okay, today we are going to go through Scala, and we are going to try to understand and try to get hands-on with Scala. Okay, so first thing is what's in the name? Scala, scalable language. Okay, it's a multi-paradigm programming language designed to express common programming pattern in concise, elegant, and type safe. Okay, it may not mean anything to you right now. Okay, the most important part is yet to come. It is more like Java, as in you have to define the variable type, okay, which is statically typed, unlike when we are defining a variable in Python in shell, we don't really specify a data type. You let it infer on the runtime. Okay, so in case of statically typed languages, the data type is it tries to infer as much as it can during the compile time. It tries to infer the data type during the compile time. Okay, so a lot of situations can be handled in the compiled languages. A lot of situations can be handled such that, okay, such that you don't get it, you miss a problem till it goes to the production. Okay, because everything gets caught during the compile time. All right, the next thing Scala provides you is lightweight composable syntax. Okay, this we will see as we go forward. It is stable and innovative. Okay, we are going to look at these examples. Although every language, if you try to take a look at Python, PHP, and Java, you will find, except for the first point, you'll find the rest of things very similar. All right, Thomas, the sound is okay now. All right, all right. So I had put it in the on my neck, the headphone. That could have been the reason. All right, so let's skip the theory. Now this is important. What is important here is Scala is not a new language. Okay, Scala was created in 1990. Okay, at the time when Java was in very initial stages. Okay, Java must have been in Java 1.1 or something. So essentially, Martin Odersky created Scala. It basically made a better Java compiler than the usual Java compiler. Okay, and that was something amazing because Java guys tried to make Java really fast, but Martin came up with a better compiler. Okay, and actually in 2001 it created a better Java, as in decided to create even a better Java. And in 2003, first experimental release was done. Okay. In 2011, it started getting adopted in the corporate. Okay. So the single reason why you would like to use Scala over Python on Spark is Scala is far more faster than Python. Okay. That's a single big reason. Second, Scala is kind of, you have to define types upfront. And the other reason you would like to use Scala with Spark, the other bigger reason, one is it's faster. Second is most of the APIs of Spark are written in Scala. So, all right. So Thompson's question was, what was the first reason? First reason was the most important reason. The first reason would be Scala is pretty fast. The reason why Spark guys wrote Spark in Scala is because Scala is faster than Java. Okay, as per their statistics. Then second reason is since Spark is written in Scala, therefore the default APIs are always available in Scala. Okay, the default because we are talking always with respect to Spark. Third reason, okay, so the second reason was the API of Spark would be latest in Scala. Third reason is the components of Spark, such as GraphX, the new components, they are made available in Scala earlier than any other way. Even in the GraphX is not yet available in Python. So it was kind of a separate project, Ted, at that point of time. It was basically nobody even knew that it is going to be a separate language. Okay. So good question, Aslan. So Scala is not limited to big data or few other fields. It's a kind of general programming language. Yes. It's basically uh, it's basically more like Java, just very brief or very succinct syntax. Okay. So if you combine Ruby with Java, you will get Scala. That's the kind of thing. So yes, it's a general purpose programming language. You have web applications in Scala, you have web application frameworks in Scala, and you have parallel computing in Scala, and so on. Okay, good question. Yes, that's true. So Scala source code gets compiled to Java bytecode. Okay, which means, so if you guys remember, in case of Java or C Sharp, right? When they compile to an intermediary language. Okay, they compile to intermediate language, both C Sharp and Java, and that intermediate language is interpreted or run by the virtual machine, not the virtual machine of Hadoop. It's a layer which basically runs that intermediate language. Okay. In case of C Sharp, we call it IDL. In case of Java, we call it bytecodes. Okay. So basically, why was it done? The intermediate code so that the compiler could evolve in its own at its own pace, while virtual machine could evolve at its own pace. And as and when new Java compiler is launched, it is not mandatory to upgrade the virtual machine. Okay, so that was the sole idea behind behind compiling it to intermediate code. Also, unlike C code need to be compiled for particular architecture. So that kind of thing doesn't need to be done for Java. Java's code is generic. Yes, it is object oriented. So resulting bytecode actually runs on Java virtual machine. So if you have built a piece of code and you're trying to run in production, and in production there is only JVM, okay, not Scala, it will still run fine. All right. Java libraries may be used directly inside Scala code and vice versa. All right. So, all right, let's all of you get into console and start with a simple exercise. Okay. Okay. So all of you, please log in into the console. A question from Manjunath. Does Scala have their own JVM? No, it runs on Java virtual machine. A question from Nada, that is it object oriented? Yes, it is object oriented and supports entire features that Java supports. Okay, and it is so object oriented that it doesn't have primitive types. Even the numbers are objects. All right. Good. So please, all of you, Mohit's question is Scala more versatile than Python? Okay, there I'm little biased. I'm little biased towards Python. So I will always say that Python is far more versatile. Python being a dynamic type language, so values can be inferred in the runtime. So generally, Python would be more versatile than Scala or any other strongly typed language. Good question, Mohit. All right. So is everybody able to log in into console? Scala is faster, Kush. All right. Scala is faster. All right. So here on the console, what we are going to do is, okay. So you type a command called Scala. All right. And there you try the simplest program called 2 plus 2. All right. So you can see that there was a temporary variable res0 was created. Okay, which says the res is of data type called int, okay, and has got value as 4. So res0 is an integer, which is a temporary variable created by this. So Ali's question is, in big data, does it matter to use faster language? It's a very interesting question, Ali. Let me try to answer this in multiple ways. Okay, all right. All right. Okay, so who can answer this? Yes, so I have the same opinion as Ali. Generally, in the big data projects, big data projects, few milliseconds here or there in the execution does not matter. Does not matter. But sometimes when you have a billion records and There's a difference of 1 milliseconds, okay, per execution, or say 0.001 milliseconds, okay, 0.001 millisecond. That means these many seconds, and a billion is how many seconds? 9, right? So it comes to around 10 to the power 4. Okay. So what I'm trying to say here is, even though when it comes to language, there is no visible difference, but sometimes if your computing is really, really intensive, and it's more about transforming the objects from one form to another, then Scala could be slightly faster. And as per the argument which I hear from people who implemented Spark, they give me this argument that imagine that you have 1 billion record, and the difference, let's say, between A program and B program is around 1 microsecond. Okay, 1 microsecond. Then it'll be around these many seconds. All right. So they as per them, this is huge number. Okay, few minutes. So 1000 by 100 by 6, which is how much? All right. So this is around 17 minutes. So you see that even though in case of 1 billion record, the difference was around 17 minutes. It's not a big deal. But yes, uh, why we are studying is mostly because Spark guys took the call, and as per them, as the data keeps on growing, this time will keep getting slower. Yeah. So that's not, in my opinion, that's not a big deal. But for the people who were working on Spark, for them it was a big deal. Okay. Correct. So yes, Ali says that I'm a data scientist. I need big data for my job. Other languages do not come with my libraries. Yes. So basically, I totally agree with you, Ali. And whenever I'm solving a problem, at times I combine these all approaches. I try to combine all these approaches, and therefore the languages do not matter. What matters is the libraries that I'm going to use. Let's say I'm going to process videos on big data. I will end up using MoviePy most likely. Similarly, if I'm doing the scientific computing, I might end up using SciPy along with the Python Spark. Okay, so yes. All right. So if you want, we can take you through through a small walkthrough on how to use Python along with Spark. Okay. So I can take you through like 15 minutes of that. Okay. All right. Sure, I'll do that. Satyaj's point was, I think if frequent repetition of a particular execution isn't requirement, it pays to have faster language. Yes. The big deal is scalar components are available for Spark in the meantime. Yes. Basically, the problem arises when uh, the Python APIs are not up to date. Okay, Spark's Python APIs sometimes do not have newer methods because they are coming later. And for example, GraphX isn't available in Python yet. Okay, so these are basically the reason why people prefer. Okay, and then I can say Scala is little faster. All right, so the other reason what I found is that when people do the deep learning kind of computing, okay, in case of the say machine learning kind of computing, where CPU, I mean the processing is higher CPU, has higher CPU consumption. Okay, so processes have a higher CPU consumption. In those cases, better but Scala works better. Okay, because when you have more CPU consumption, the most of the time is going into unboxing the data. Okay. All right. So these are the few reasons. Yes. It was a healthy little discussion on comparison of programming languages because comparison between programming language is equal to the political comparisons. Okay, so the comparison between programming languages, editors, operating system, and religion and the politics, they all lie in the same same bucket, and that's where we as a data scientist or developers, we need to just figure out what is the tool that that what is the tool that solves our problem. Okay, so yes, all right, great. So, and I'm of a very big of a very strong opinion that there is nothing wrong in learning a new programming language, but you may not be able to master this new language, but you may be able to get it done. Okay, so I started my career with learning Perl. My first web application was in C++. Web application was in C++ before Perl came into play. Then I almost learned almost all other programming languages till date. Okay, but having said that, my personal favorite is Python because it has almost every library for me. Okay, all right. So great. We are able to do 2 plus 2. That's a big deal actually. Okay, so let me do a few more things. The other things we could do, print hello, and all right. All right, so okay, Arslan's question is, I'm in databases and data warehousing, and sometimes we need Java, and I'm not good in Java. So do you think Scala can help me in BI world? It should be able to help you in BI world. I just need to see if, because in BI world, let's say you are using BERT, for example, okay, there you would need JavaScript, not Java, okay? And let's say you are using an ETL tool, there you will need JavaScript, not Java, right? So, okay. So I think for those kind of use cases, you might have to look at the domain specific language. What domain specific language you generally use. Okay. All right. So everybody is able to say hello world. That's like saying ABC. All right. So the other thing which we are going to do is define our first function. Okay, called hello. And it's going to be look little tricky, but it'll be okay. Okay. Are you able to use it? There are only minor differences in the syntax from Java. Okay, so this was the way we use interpreter. We call it REPL. It's a REPL, as in this console is REPL in the sense that it reads, evaluates the command you give to it, and then print and keep on looping it. So it's a read, evaluate, print loop. Good. So, all right, you might be able to see inside your lab all these details. All right. The other thing which we can do is we can create a script just like Python script by using nano. Okay, so I'm going to say nano hello world.scalar, and I have already put print hello world inside it. Okay, and then I'm saying I've saved it, and then I'm saying okay. So the first statement opens up the editor. Inside the editor, type this, then press Ctrl X and save the file. And once the file is saved, execute it using Scala. Yes. Okay. Is it working for you? Let me show you. All right. Okay. So Ramna, what error are you facing? Let me give you the control. You can share your screen, Ramna. It's okay. You share the entire desktop when you click on share. Yes, I can see the. All right. Okay. You have to exit the Scala to type nano because nano is. You can press Control D. Control D. Yes. And then say nano. Good. Here you can write. All right. Karthik, you are also seeing this? Yes. Press ls, type ls, enter. Okay, so you can see that you have put extra y in the file name. Okay, you can see hello world.scala y. That's okay, it's not a problem. Okay, so those who are new to console, they can please note few of the tricks. You can always type tab and it will auto complete the file name. Okay, so now type scala, SCA space h and type tab, h, type tab. Yeah, it should auto complete. Enter. Yes, it worked. All right. Print and println is same thing. Good. Good. All right. Any other? Okay. Sapna and okay. Karthik solved the issue. Yes. Extension doesn't matter. Yeah. In any of the Unix programs, extension does not matter. I'll tell you one more trick. Okay. So the way Unix programs work is by looking at the first line. Okay, let me just see where is my Scala program. Okay, so it's inside user bin. Okay, so in the first line of this program, I will mention this. Okay, now if I made it executable, right, it should now ideally work. It looks like it doesn't work. It should work generally. All right, never mind. So generally the programs make it possible to run it without the, okay. No, I think it's a correct one. I think uh, this Scala does not support it. Yeah, it says script file does not close its header with, interesting, interesting. So it doesn't work that way. All right, I'll have to take a look. Generally, all the programs like Python, R, and others, they basically can run without this. All right, thank you. Let me try to incorporate what is bin bash Scala. Is that the one you're talking? Okay, so I should say user. I doubt if that will work. I doubt that'll work. No, it won't work. Never mind. So basically Scala doesn't support this kind of feature for now. Okay, so we have created this file. Okay, then we are saying Scala and hello world. Okay. In general, in Unix world, the extension does not matter. It's only in case of Windows, when you double click a program, Windows wants to figure out based on the extension with which program it needs to open this particular file. Okay. So Sapna, okay, for Sapna also it worked, and Karthik also, and everybody is in line. Okay, is anybody stuck at this point? Good. All right, moving ahead. So this was our first interaction with Scala. So we have done two modes so far. One is the REPL, the read, evaluate, print loop, as in the interpreter. And the second was scripting way. Okay, we haven't compiled the program yet. Okay, let's say you just want to execute one scalar command. You can also use this way. It is kind of Unix command way of doing things. All right. So the next one is compiling. All right. So we are going to use the another one called, say, HW. Okay, HW. All right. And then inside the file, we are going to save this. Okay. So hw.scala, and then inside that we are going to put this. All right. Class name doesn't need to be same as far as I know. Let me just see if that gives an error. Okay. So the next thing I did was I compiled it. All right. Thank you, Ali and Prakash. Let me try doing this at later point of time. Looks very interesting. And okay. Now, so right now, what we are trying to do is, let me save what Ali's and Ali has suggested. Right. Okay. Good. I'll put it in the beginning and then we'll try. Okay. So what is it that we are trying to achieve now? We're basically creating hw.scala, and then inside that we are putting this piece of code. Okay. And then we are saying Scala C. Okay, so we are saying Scala C hw.scala. All right, here it will create. I think what should I do is I should go into a folder called Scala, move my work here. Okay, because it was becoming too confusing. All right. All right. So what I have is a HW class. I did hw.scala, and all I have to do now is compile it, Scala C. Okay. So when I compile it, you will see that class has been generated. Okay, class has been generated. And in Unix, there is a file command which can actually tell you the information about any file. It tries to understand the data inside the file and then prints what it has. So you can see that it's a Java class data. Okay, it's a Java class data. And to run it, so it has created three classes. You can see one, not this one, is this is not ours. Sorry. Let me delete the class again. It generated three classes for us. When we compiled, it generated three classes: hello world, dollar, hello world delayed init, and hello world. Okay, so hello world is our class because that was the name of the class here. You can see it was the name of the class here. All right, now we can say scalar hello world and we will get the results. Okay, so first we did scalar c hw dot scalar. All right, good. So when we did scalar hello world, right, it should work. Is everybody able to run scalar hello world? Notice that we are not saying hello world dot class. We are simply saying hello world. Okay, question from Kush is why are three classes created? So that's an instrumentation done by Scala compiler. Okay, so inside it, there are basically three inner classes. Okay, inside this, there are basically three inner classes that it creates. And because of that, there are three hello world classes. All right. So internally, it has three classes. So a question from Jitendra is, can it be executed using Java class name? Yes, it can be, provided you provide proper libraries for it. Okay, you provide proper libraries for it. All right. So, all right, I'm just trying to see what is it there in the file. It says that it's a Scala, which is a command, is basically a Unix shell script. This is nothing but a Unix shell script. If you take a look at this file, I'm using Vim, you can use anything else. And so I'm just trying to take a look at something here. So you can see that this scalar command is nothing but a wrapper over Java. Okay, it's a wrapper over Java. So you can see that it says Java command equals to Java. And inside, at the end of the whole process, Scala internally is executing Java command. Okay, does that answer your question? So this Scala command is nothing but wrapper over Java. Just that before executing Java program, it puts the Scala jars in the UR in the class path, so that all the libraries can be found by Java. Okay. All right. Which one are we talking here? This one, Manjunath? Oh, this one is actually it's a shell script. The Scala, the Scala program that we used, it's a shell script. Okay, it's saying env bash. Yeah, all right. Yeah, both of those are valid. We can try that out actually. Okay, that's all right. That's all right. It's not that important. Good. So what was important here was to know that Scala, class runner, the one which is running the class, is nothing but is running the Java. Is running the Java virtual machine. So Scala virtual machine, it answers the another question as well, that the does it have its own virtual machine? Answer is no, because it's actually executing Java, which is the Java virtual machine. Okay. All right. Now you know how to figure out. Let's say what I did was first I said which, and then I looked at what is there inside it. It said it's the file at this location. Then I said file and slash user and this location. Okay. And there I came to know, okay, it's a shell script. And then I edited it using nano. Don't edit it. Just for the sake of navigating through the file. All right. So this way you can generally figure out what is where and what program are you running. Yes, basically Scala compiler does the magic to improve performance. Good. Great. Great. So this was a great discussion. All right. So we are able to all are able to run it. Scala Hello World. Yes. Is anybody stuck? I no idea. I'm trying to answer Anoop's question. Anoop is saying if you run this one, which one is it running? So let me take a look at this. Okay, it's the same one. Yeah, Anoop, you can see the Scala is actually a pointer link to the same user share Scala folder. Okay, so answering to Priya's question. So yes, so Priya, you have to do this because it is with respect to the previous folder. So it means slash user slash bin dot dot and then this. Okay. All right. Great. Great. Wonderful. All right. So we all are able to compile and run. So we have talked about 4 methods of running. One on the interpreter, right? Second, like a script. Third, like a Unix command, like this, okay, like a Unix command. And fourth, like a Java program. And any programming language or a compiler these days provide at least 2 to 3 modes of running it. All right. Now, before we jump into anything, we have to define the data type upfront. Okay. So we'll spend more time on the interpreter. Okay. So we are going to say where x equals to 1. This is also valid. Okay. Or we could say, well, y equals to 2. Now, what's the difference between where and well? If you try to modify y, it will give an error. While x can be modified. X can be modified. So that's a big difference between where and well. Well is non-modifiable. Where is modifiable. So where varies, but well does not. Okay, so that's the difference between where and well. That's the basic way of defining a variable. Okay, this is how we define a variable. You can also be, you can also define the data type like this. Okay, so here, Saptrishi, here there was no need to define the data type, but you will see as we move forward, a lot of places you will have to define the data type. Okay, so is it clear to everyone? Great. So are you guys trying along with me? Where, well, and then with the data type, without the data type. Okay, so you can see various data types. Now, at the same time, you could also define the names, okay, meaning strings, all right? And then when you're using println, you can use the variable. Yes, well is a kind of non-modifiable. Okay, and the string way, the way it handles the strings is similar to the way Java handles it. If you want to put double quote inside the string, put a slash before it. And if you want to put slash inside it, put slash, two slashes in it. Okay, you can see the slash double quote has gone into the string. Good. All right. So we can also say well where name is string. That's a way of explicitly saying that it's a string. All right. So you can define the underlying, without defining underlying type, you can define the string this way. Okay. So let me move that point to here. All right. And move from here. Okay. So you can also say things like sum equals to 1 plus 2 plus 3, which is pretty straight. Sometimes you want to create an array. Okay, array of values. Now please note there are two things. One is list, other is array. List cannot be modified while array can be. Okay, so you can see that we are defining an array where we can access individual value. Okay, so are you able to define an array? So array can be modified, but list cannot be. I'll show you. And the way you modify an array, let's say you want to append something to it, all you have to do is say colon plus and put some value. Now you can see that it's being appended to the array. Okay, so you will have to say my array equals to my array plus, all right, I'll say where, only then I'll be able to modify the reference. Okay, so you'll have to say my array equals my array this. All right. All right. You can see that I'm adding it again and again. All right. And here you can also say print ln my array. Okay, that did not work. So you can simply say this. Okay, I'll show you in a minute how to iterate over an array. Let's say you don't have anything to define by default. In those cases, you will have to define your array this way. And you're saying here that you are defining an array with these three values. Okay. Question from Ali is where list equals to where array? Where list equals to val array? Not really. In case of val, you can't reassign the variable. I'll show you this. Okay. So, all right. So let's say I'm saying val my array. Okay. And all right. Now, so basically, you can't reassign you can't reassign the value, but you can modify it. Okay. Even though my ARR is 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 um is a val, but you can add 4 to it and create a new array. It is creating a new array. While in the case of list, you can't really add anything to it to create a new list so easily. But you can wrap it into another list and do. So yes. So in a way, you are right. So in a way, you are right that the whole idea behind having array and list separate is to have mutable and immutable separately. Okay. So Scala has tried a lot to keep immutable and mutable separately. Therefore, in Scala, there is a separate collection. The data structures that Scala provides are in two separate folders, immutable and mutable. Okay. So Ali, in a way, you are right. Okay. Karthik's question is All right. Are you able to hear now? Okay. I hope you are not having the beat again. Yes. All right. So this was our quick discussion on the data types. Okay. All right. So we talked about the basic variables. We talked about two things, array and list. And the quick way to understand what all methods are supported, just press dot and press tab. Okay. So you can see 2 plus 3 plus 1. That was quick. If I have to check the length, I can, I think, say length. Yes. And so on. There are quite a few methods provided on array. You can see here. Okay. All right. Let's take a quick break of 10 minutes and be back. Hi everyone, I'm back, so we can start now. All right, is everyone back? Should we start now? So we talked about how to execute the basic Scala program, and afterwards, the basic two kinds of variables, where and val, and then we also talked about the basic data types, string, number, and list and array. Okay, so another it's another class called map. There are it Scala has a very rich data structures, set, hash set, hash map, everything is there. So whatever is there in Java, it also has the same methods. All right. So the way you define map is little strange for the people coming from other programming languages. So here, this is your variable name. Let's say my map. Okay. This is equals to map, and then I'm saying ABC and list. Okay, so it's saying that this is a map where the key is going to be ABC and this is going to be a list. Okay, the other way of defining the same thing is by using this kind of mechanism. You could say am equals to new this. Okay, I think this is the right way of defining it. Yeah, this is another way of defining a map. Okay, and you could always say m plus equals to another key and then another value. All right, so this way. Good. So either you could, if you have by default some value to put in, you could define it like this, or you could define it like this. Here we are saying list, but in case you have another string as the value. Okay, those who are not aware about a map is the most commonly used data type. This data type has key and the value. You can address any key. If you can retrieve any value by specifying key and so on. All right. So here we are defining our map like this, and we can add more values to it in this following manner. So this map has got two keys and two values. First key is ABC, second key is XYZ, while the value for the first key is 1, 2, 3 list, and second second value is another list containing 4, 5, and 6. So no, you cannot use double quote instead of a quote because quote means a single character and double quote means a string. Okay, so you can see here. So it's a char. While if you say double quote, it's a string. See the difference? All right. So list can have multiple data types? No. List cannot have multiple data type. As far as I know, list can only have, let's try. As per my knowledge, list was only supposed to have, nice, list can have any data type. All right, let's try an array. Let's try an array. Oh, nice. So array also can have different data type. So in that case, the data type of an array is going to be any. Okay, this is an important part. Array, the data type of array is going to be any, because any is something from which everybody inherits. Okay, Arslan's question is, what's the practical use of a map? Map is, you remember our word count problem, right? There we were trying to maintain an in-memory map. So wherever you need to query something based on a string instead of a number, you use an array when you want to query something based on an index, right? But if you have to query something based on a name, then you use a hash. You use a map. Okay, you use a map, because map is just like a dictionary in which you have key, which is a word, and value, which is the meaning. Yes, thank you, Manjunath. So that's more correct answer, that when you want to fetch something in O1 time, as in constant time, then you use map. All right. All right. So if you want to delete something from a map, you can simply delete it using this way, and it's removed. Okay. So do you guys want to try it out? All right. I'm going to. All right. Good. Is everybody able to execute this? All right. So now the functions. Functions are more important for us because in our case, we are going to use mostly functional language, not the object-oriented part. So because most of the data-oriented problems are functional in nature, so we're going to use more functions than the object-oriented programming. So let's try to create the most basic function. Okay, so this is the most basic function where this value gets returned when you call square. Okay, so it's pretty straightforward. I'm also copy pasting it here. All right, so I'm going to say square 10. You can see that I'm able to execute this function. All right, so this is the most simple way of defining a function. So by default, the same value is returned. If it's a single expression, the return value. So here, let me explain what does it mean. Def is a keyword. We are saying define. Square is the name of the function. X is the argument. Int is the data type of argument. And colon int, this is the return value data type. It's a data type of return value. All right. You can also put curly brackets. If you have many statements, then you can put curly brackets. If you have a single statement, then you don't need to put curly brackets like this. Okay? All right? Question from Ted. If you don't define the return type, does it apply type inference? Uh, no, it doesn't. Okay? It doesn't. It basically, thank you, Ted, for that question. I also earlier thought that okay, it'll infer, but it does not. Okay? You can try this here. If you try to do this, it's going to, oh, it did actually. All right. In case of, nice, it did actually. Yes, you are right. All right. Last time I tried, I used some other mechanism. Okay, that time it was giving me error. All right. So good that it basically inferred the data type of the known values. All right. Yes, less code, the better. All right, so let's try to do something meaningful. Let's try to compute interest. Okay, so let's define the interest. Let's define a function called interest and compute the value. Okay, so now this is a function interest which takes three arguments: principal, rate, and time, multiplies the three, divide by 100, and returns the value. Okay, so is everybody able to execute it? All right, wonderful, wonderful. So I hope interest is interesting to everybody. All right, good, good. So this is like something you can do in any programming language. So we have just created our first function called interest. Now, I would want every one of you to calculate tax. Okay. Okay. So this you can probably take as an assignment. Yeah, you can take this as an assignment, and this slide is shared with everyone. Okay, so the problem statement here is that given the income range, there is a tax implication. If if you have got a salary of 300,000, okay, it's not dollar, of course, it's in INR. The tax is zero. If the tax, the sell income is between 300,000 to 400,000, the tax is 10% on this slab. Okay, and if you have salary above, say, 400,000 up to 500,000, then tax is 20%, and for this slab onwards, the tax is 30%. Okay, so let's take an example of 400,000. So 400,000 is here, right? So Okay, so 400,000 is here, which means for 100,000 you have to pay 10%, and for remaining you don't have to pay anything. Okay, that means it's going to be 10,000, right? So I hope the problem statement is clear to everyone. Okay, okay. So I think there was one important part that we left. That was what Saptrishi is saying, that in case for readability, if we want to write the functions in multiple lines, you can write that. Okay, if you're putting curly brackets, then you can write in any number of lines. Okay, so try to do the computation of the tax. All right, and you should be able to do that. Okay, what I would want to display here is, this is my rudimentary approach. Okay, here I'm defining a function called compute tax. This is the total income. Here I'm saying if income is greater than 5 lakh, then I compute the tax above 5 lakh and reduce the income by 5 to 5 lakh. If the income is greater than 4 lakh, then I do this and so on. Okay, so I'm going to just copy paste this piece of code, and all right, sorry. Okay, so this is the function which I have written. You can write in your own way. Okay, you can write it in your own way. All right, let's test if it's working fine. So for 3 lakh, there is nothing. For 400,000, there is 10,000. And for, you can see, good. So it's able to run fine. All right. So the things that you need to pay attention here is this function. You can see that the argument here, whatever is being passed, I'm defining a variable called income, because the by default, whatever argument you get is non-modifiable. Okay, and then that's why I'm defining it to a handing it over to a local variable, and then we are okay. So you can see this. All right, is the logic clear? So you can see that if conditions are very much similar to Java or C or C++ for that matter. Okay, all right. So you can make improvement to this. All right, I have defined something called slab text and I've tried to do computation, but it's not that great. All right, so that was our first encounter of a function and if condition, right? And then let's move on to something called recursion. What is recursion? Okay, A question from Saptrishi is there any command to see the list of existing functions? So list of existing functions are always against an object. So you type the name of the object, put dot, and press tab. Okay, it should show you the list of existing functions. There is no other way that I know of, okay, that can display. I okay, so I'm not sure if there is a way to. Oh, thank you, Prakash. All right. So that's not related to the not related to the. All right. I do not see any way of seeing the documentation from here. Yeah, there is no similar one, Anup, but you can see, let's say we have array object here. What was the, let's say where x equals to 4. So x dot, you can see there are too many, the values. Okay. Similarly, let's say s equals to 45.67 and I say s press tab, shows me all the functions that are part of it, you can see. And what I can see here is uh, I can call many methods on this string. So you can see I have two long or two int, two float. So let me see. So where s equals to this and s dot to float. So you can see it's returning 45.67. All right. So basically there are ways to find out the list and then call. Okay. A question earlier asked by Jin. What is wrong if I do define any function? So any has to be some proper name. Okay. It has to be a name because any is a keyword. The function name. Okay. All right. Let me see. All right. Probably it's not able to infer what to do with the plus. It's not able to infer what to do with the plus, and therefore it's not able to figure out the meaning of plus. I think it's not. I'll have to take a look at it. All right. I'll just move it to above. All right. Good. Now let's move to recursion part. Okay. So just like Java, C, Python, Scala also supports recursion. What is recursion? Function calling itself. Function calling itself. Okay. So, so let's say we have to compute factorial. What is factorial? Factorial is factorial of 10 is equal to 10 multiplied by 9 multiplied by 8 multiplied by 7 multiplied by 6 up to up to. Okay. So this is what is factorial. All right. So whatever number you give, you keep on reducing it by 1 and keep on multiplying it. Right. Now question is that how would you implement factorial? One is by using a loop. right? You can use a while loop, okay, and then keep on increasing the value. So let's define factorial of x, which is integer, and we are saying curly bracket, and we are saying where I equals to x, okay, while I is greater than 0, and we'll also say result equals to 1 while I is greater than 0. We keep on multiplying result equals to result multiplied by I, and I becomes I minus 1, and then okay, and I say print ln result, and that's pretty much. Okay, one more thing, you have to make sure that the type is it is type safe, as in it's a uppercase. So I is capital. All right. So now you can see that fact of 2 should be 2, 3 should be 6, 4 should be 4 into 6, right? And 5. Yes? I hope I'm not boring you with my coding skill. I'm pretty slow. This is not recursion. That's correct. Okay. All right. So Arslan's question is, like we execute Unix with -x, is there a way of debugging? Yes, there is a way to debug this code. And actually, in the Eclipse, you can debug stepwise. Okay, it provides you a way to debug things stepwise. Okay, so you can right now we are coding everything inside console, but you can use Eclipse, and from Eclipse you can once everything is running, then you can copy the data, copy the code to console and run it there. All right, so this was factorial. It looked simple, and sure, I can give you, but I don't have Eclipse. Maybe next time we can give this. It might take decent amount of time to install. All right. Or I'll try to see what IDE people are using these days. Okay, so yeah. Let's try to compute factorial using yes, IntelliJ is a good IDE. All right. So here it's pretty simple. If I have to say x greater than 0, if x less than equal to 1, then return 1. Okay. Otherwise, return x into factorial of x minus 1. All right, but for that, this method needs to have a return type. Okay. IntelliJ, yeah, IntelliJ is good. All right. So Scala supports recursion completely. All right. And here it's even brief. Good. Any questions for me as of now? All right. This is an interesting question. Yes. Okay. So question is that is there any language which does not support recursion? Has anybody seen such a language? Okay. So yes. So there are a couple of languages which are there which do not support specifically the domain specific language. Okay. Domain specific language. We were using some proprietary language at DE show that did not have the recursion. Okay. And for that it became kind of difficult to code. All right. So idea here, okay. So almost every programming language has support for recursion as of today. And here the idea which I'm trying to define is that in a procedural language, we are going to use functions a lot more. Okay. In a functional language, we are going to use functions a lot more. Okay. So a question from Arslan is, Scala has its own libraries or we can use Java library? You can do both. Scala has its own libraries and you can use Java libraries as well. All right. All right. So now starts the more functional part. Traditionally, we are quite used to using a for loop or a while loop. Okay. But in case of functional languages, they provide the syntax that's very much closer to closer to okay. So most of these programming languages which are functional in nature, they try to avoid a lot of coding by using these neat functions such as map, for each, reduce, and so on. Okay. So every programming language, functional programming language, has the map reduce functions in them. Okay. So let's take a case of this list. It has 3 values. Okay. I can execute a function. I can execute a function on every element. Now here, what we have done is we have defined a function, anonymous function, then and there. This is an anonymous function. What does it mean? What does this representation mean? It means x is the argument to the function and print x is the body of the function, and this is a function itself. So you can say that this is equivalent to saying def f and x int, and then saying equals print x. So this is equivalent to this. Okay, these two are equivalent. This syntax and this syntax. Just that here there's a name of the function called f. Here this function is anonymous. All right. So we are saying execute this function on every element of this array. Okay. You can see that. That also means that if I say x into x, it's going to print squares. Good. All right. No, you cannot update the list that way. All right. I'm going to take another example where I say x this list. So this is a little different from our for loop. Okay. All right. All right. So here we have two ways. One is using this mechanism, and second is using this for loop. Okay. What is the difference between these two syntaxes? Do you see this? This means execute this function against every element of the list. Okay. So Ted, that if you want to update the list or generate a new list, in that case, we'll be using map, not for each. Okay. Can we define custom type in Scala? Yes, we can define our own class, just like we define in Java. All right. Next question is, we can't update list in Scala means we can update existing value of the list, or we can add new items in the list. So the list cannot be modified or updated. Okay. The list cannot be modified or updated. But this variable can be changed. You can change this variable. Okay. So let's say you want to say again, assign something to it. Okay. If you're saying well, then you can't change the value. Okay. If you try to do the same thing, assign a new value, it's going to give an error. All right. I hope you get the difference. So if you are using this, then this statement will become invalid. But if you are using where, this is possible. Okay. All right. So now we see two ways of iterating. One is this, other is this. What's the difference between the two? Conceptually, what is the difference between the two? The first approach can be distributed. Yes, thank you, Thomas. First approach can be parallelized, while second approach you can't touch the code. Okay, if the programming language it changes the implementation of for each such that this piece of code can be run parallelly, right? It can be run parallelly because this has to be executed against every element. Now, irrespective of in what order, it doesn't matter to for each, right? It could do it internally and parallelly or on many machines. Okay. While in this case, the code is opaque to the compiler and therefore the compiler cannot really parallelize it. Okay. All right, let's take one more example. All right. Now you can see that even if we execute it this way, it will also result in the same thing, right? Now, here is an interesting idea. Okay. There is another function that list provides to us. Okay. That's called map. What does map do? It basically translates every value into another value. Okay. So I'll show you. So let's define a function called square. Okay. It takes an integer as argument and returns an integer, right? It returns an integer. Okay. Good. Everybody okay with this function? We have defined sq as a function which takes 2 as any number as argument, multiplies it by itself and returns the value. It squares it. Now, let's say that we want to execute this function against every element of the list and save the results in another value, another list one. Okay, we have to say where. So now you can see list 1 contains 149, list contains 123. What exactly happened? We executed this function square against every element of the list. 1 became square of 1, 2 square of 2, 3 square of 3. Okay, is everybody clear about the map function? Now this is the place where does the MapReduce come from. Traditionally, in all these functional programming languages, we have been doing MapReduce for past 20 years, right? It's just the Google guys designed the idea around MapReduce. That's why they called the framework as MapReduce framework. All right, is it clear to everyone what does map function do? Why I'm insisting? Because Spark also provides similar functions. Good. Now, what's the difference between iterating over list and this? Again, the same difference. Map internally can execute your square function parallelly on all the values. Okay, or it can distribute the work somewhere without you having to change your logic. Your entire code can be distributed. Okay, so that's the entire trick in the distributed computing or big data programming, to write the code in a way that it can be distributed, as well as make sure that it is distributed. Okay. So your whole intention of programming is to make sure wherever there is a big data, make sure the work is distributed. All right. Okay. All right. Let's say you want to multiply everything by, say, 2. There is another neater way of doing it. Okay. But this is not right. Okay. All right. I'm just trying to see. So Thomas' question is the difference to Hadoop map is that we always have one result per input line. Not really. Yeah, that's correct. That's correct. Sorry. So in case of Scala, the map function can only give single value at a time. Thank you, Thomas, for that point. So yes. So you can see that list one had 3 variables, and so was list. List and list1 both have equal number of elements. All right. Okay. So in case one variable is generating many values, in those cases, you can have flat map. Okay. You can have flat map. All right. I think this is right way. Let me try doing this. Yes. So in case of it also provides flat map. We'll discuss flat map and these things again. Okay. So now you can see list2 and list. All right. So here you can see that what we did was for 1, we generated 1, comma 2. For 2, we generated 2, comma 3. And for 3, we generated 3, comma 4. This is what we did. Okay. We'll address this again when we talk about Spark. Okay. So this is the way we deal with things in functional programming. All right. A question from Manjunath: why Hadoop didn't use Java functional programming language? So that time Java functional programming did not come. I'm guessing that you're talking about Java 8 and Lambda, right? Yes. So that time it did not. It wasn't there. And second, the framework was such that it did not provide REPL kind of model. Okay. Right. Yeah, but it's anyway getting kind of replaced partially with the Spark, so nothing to worry on that front. Okay, so list also provides very clever methods like filter, whereby we could provide a method in the argument which acts like a qualifier and only lets go of the values which qualify for this method. So here we are saying list.filter and passing a function. What does this function do? It checks whether the it checks whether the value is divisible by 2 or not. Okay, so it's a function. I'll try to I'll uncomplicate it. Okay, I'll try to uncomplicate it. Okay, so let's define a function called is even. Okay, is even, and we are passing x as an integer to it. Okay, and it's returning bool. I think bool is the correct keyword. Let me check where x bool. Yes. Okay. So is even returns boolean. All right. Is even is a function that returns a boolean value, and it returns if okay, it basically say return x x divided by say 2, meaning the remainder should be equal to 0. Okay, so we are creating our function called is even, and is even, you can see, good. So it's working fine. All right. Now let's say there is a list and we want to only keep even numbers. Okay, so we can say list dot filter is even. So you can see that the new list only has 2 in it. Make sense to you? All right, good. You want to give it a try? So the same thing is written in this form. Okay, same thing is written in this form like this. Okay, here it's 0. So you can see, so these two are equal. We are first defining a function called is even, then applying this function on every element, and only those elements will be left which qualify is even. Okay, so you want to give it a try? All right. Okay, so you can give it a try up to the first filter, up to here. The result of this part will be equal to result of this part. Are you all with me or have I lost you? So Jin, Nada, Saptrishi, okay. Oh, looks like quite a few of you are still awake. All right, good, good, great. So any questions at this point? Because this is the core idea behind Spark as well. That's why I'm spending decent amount of time here. All right. All right. The second idea is very interesting. Here comes the reduce. Now, what you see here is a very interesting aspect here. It is basically we are defining my function called add. Okay, it takes two variables, both integers, right, and returns an integer. Okay, it basically returns x plus y. I'm simplifying it. Okay, I'm making it look really nice. All right, nice. Now we can say list dot reduce add. Now list could have many values in it. Okay, list could have many values in it. Okay, so let's say these are the values and we want to sum it. Do you think it will work? Please note that this add function is only adding two values at a time. And we are saying list dot reduce and we are passing entire. Okay, so entire list we are calling reduce and we are only passing this add function. Will it add all the values or will it add only first two values? Okay, let's take a look. All right, let's see. Good. Nice. So it has done the computation and calculated it to be 58. Okay. So list.sum is 58. Doesn't make sense? Reduce is a predefined function provided by Scala library of list. Now, how did it work? It's a single function add, which is adding two values at a time. How did it work on the entire array? Or let me ask you this. If I create a function called average, which takes two values, float, y is float, and I'm returning x plus y divided by 2.0. Okay, and then I apply on reduce. Will this work? Will this work? Will this compute the average of the list? The answer is no, it won't. Okay, it won't. All right, let me first try this and then we'll try the other one. Okay, so all right, let me try to describe to you what does it mean. All right, so how does this work? So it basically does the same thing as the, okay, as the, let's say 2, 3, 10. Okay, so this basically works exactly in the same way, the way our, what was that? Combiner was doing. You remember combiner from map from Hadoop? Okay, so it is going to add these two values. Okay, so what will be the answer for this? It'll be 1 plus 2 is 3, and then it's going to add these two, and it's going to be 6, and then it's going to add these two, it's going to be 16. Correct? Same method getting called how many times? How many times did the method get called? 1, 2, and 3. N minus 1. That's correct, right? So yes, that's correct. So it's n minus 1. Good. So there could be other strategies as well. Other strategies could be that this part is happening in case of other tools. They could do, okay, let's do it on one processor. Let's sum up these two in another processor and then combine these using another processor. So this is 3, this is 13, and this is 16. So okay, so the way it's going to be, the way it's going to be reduced is not in your control. It is up to the implementation of this function, whether it's going to reduce the adjacent values, or is it going to run in many computers or many threads or elsewhere. Therefore, while handing over the methods to reduce, you have to make sure that it is idempotent and what was the word? Commutative. Commutative and associative, not idempotent. It is commutative and associative. Meaning, if the function is applied again and again on the values in the result, still the net outcome will be the same. Okay, keep this in mind. There could be many variations to it. There could be another variation whereby these two get combined first, and then 11 and 13 get combined later, and then 12 and this get combined, 2 and 14 get combined together, and you get 16. So you can see that summation, no matter how you do it, is going to give the same result, but average is not going to give us the same results. Make sense to you? Is everybody with me? Or all right? Okay. So can anybody give few more examples that may not be good for reduce function? Like average was not good. If we just subtract, if we have a function here, if we have a function called define delta, okay? So we have x and y, and we are saying return x minus y. So will this be a good function for reduce? Correct. Because in this case, the order matters a lot. All right, great. Let's move on. So this, the other representation for doing the same thing is like this. If you have two argument in the function, you could simply say this. All right. Now in Scala, you can define a class in this manner. Okay, you can define class, person. These are the constructors, values in the constructor. Okay, so that when you create the person object, you can use this kind of mechanism. Okay, let me show you this. All right, and here we go. All right, so you all can try this. Everybody, do you want to give it a try? Okay, so while you try, I go through it once more. So we are defining a class which takes these a name and an age as the argument. We are just assigning these to local variables and then printing the value. Okay, let me try to do some more improvements to it. Okay, so the other way we could do is we could say as here, this is one good syntax, and we could say dollar here. Let me try this. Let me try this. All right, this works. Okay. All right, but these two are no longer variables available to us. Therefore, okay, they, right. Therefore, this is invalid. Good. All right, so everybody has tried this piece of code, the one I have shared with you. Is it clear that you can create your own data types and how you can compose your own complex objects? So you can define two variables. You can define your member variables and so on. Percentage D is for printing the number. It is just like C or Java. All right. Next thing is Scala provides a huge hierarchy of collections to you. Okay. Everything starts with traversable. Then you have sets, maps, and sequences. And then you have various kinds of sequences. As in sequences is array is a sequence. Okay. List is a sequence. Linear sequence, index sequence, and so on. You have set. Set is a unique element, while map is key value pairs. Sequence is like an array or the list. Okay, so these are the various data structures provided by Scala to you. And for every one of these, there is a parallel one, immutable as well as immutable. All right. You can also use the existing Java collections. Let me try to see if we can import java.utils here. Yes, you can import Java utils. All right, you can see that. And in case you have added Apache Commons that you can use, fast utils, I'm not sure if it is available by default. Okay, it's not available. Import fast util. Okay, we'll have to put this in our library and then it should be available. All right. Okay, so we have already talked about this kind of succinct way of presenting a function, right? We can give it a name. All right. We can give it a name or we can define a function in this manner and then we can pass the function to another method and there it can be executed. All right. So we have already talked about maps. So there's nothing much to discuss here. All right. Higher order function means a function can call another function which is passed as argument. Okay. So that's pretty much, we wanted to talk basics on Scala. And as we go in the class, we are going to do more hands-on so that we become more familiar with the Scala. All right. So from next session onwards, we are going to go deep dive into Spark and then come back to the programming. Is everybody with me? So that's pretty much for today. Today we learned Scala. We got everything rolling so that we do not have any fears of using Scala. All right. Try all the example. Try to finish the exercise which I have provided. Okay. Regarding the text computation. Try to do that using Scala. Okay. And stay connected. And yes, another, I have received your answers. Okay. And we are reviewing those. All right. Great. So yes, I will send the commands. Actually, these slides are available to you in the KBD here. If you go into the course, you should be able to find those. Okay. If you go into my courses, you will be able to find all the slides already. Okay. So take a look at this. All right. Let me take a look at Hive presentation. Here, this one. Okay, so Sapna, where the resolution is not good in the PDF, the video, let me take a look. I haven't actually watched the video. You can change this to, so, so yeah, looks good to me. I'll take a look at it, all right? Okay, I'll take a look at it because I have not really reviewed the videos recorded by Zoom and I'll have to take a look at it. Okay, so that's pretty much for today. I look forward to see you next week and I hope to get more questions from you. All right, thank you everyone and have a great week ahead. Bye-bye.